The brown color that occurs in many lakes in Minnesota, especially northern Minnesota, is today referred to by aquatic scientists as CDOM, which stands for colored dissolved organic matter. People who live around lakes often refer to the color as tannic acid, but that's only partially correct. Tannic acid is a component of CDOM, but there are literally thousands and thousands of compounds that comprise the complex molecular structure of CDOM. Some people refer to color as iron in the water, but that's not really correct. Iron is often associated with waters containing high color, but the iron doesn't cause the color is actually caused by organic matter.
Sources of CDOM include microbial production, higher plants, especially wetlands and forested wetlands. CDOM is important for a number of reasons, but one of the most important is that it has strong effects on light and what happens to light in lakes and rivers. Where CDOM is abundant, it absorbs much of the light and converts it into heat and chemical reactions. And that light doesn't go into photosynthesis by plants and algae, so it actually lowers primary production in lakes. That said, you can still catch a lot of fish in dark-colored lakes. There's still fish production, but it tends to be lower overall.
CDOM itself is not a pollutant. However, it does create many headaches for water treatment engineers. It can create an aesthetic issue in that it imparts color to the water, and of course people generally prefer to drink water that is clear. We know that it increases chemical dosage requirements, for example coagulants. We know that CDOM can foul membranes used for water treatment. And then finally, CDOM does react with chlorine to form hazardous disinfection byproducts. Many of these compounds are known or suspected human carcinogens, and several classes of disinfection byproducts are regulated by the U.S. Environmental Protection Agency.
When CDOM absorbs light, the CDOM itself can break into smaller molecules, but it also produces highly reactive species like hydroxyl radicals or excited states of oxygen known as singlet oxygen. And these excited species react with the organic matter itself and break it down into smaller pieces.
CDOM has many important effects on lake chemistry. It strongly influences pH, generally decreasing pH in lakes. It also has important effects on transfer and cycling of metals in fresh waters, including iron, mercury, and aluminum. And by affecting light, it also affects the photochemical processes that affect cycling of many elements.